Our planet is warming. The consequences are already upon us. Melting glaciers, rising sea levels, and extreme weather events. The culprit is clear: human activity, primarily the burning of fossil fuels, is releasing greenhouse gases into the atmosphere, trapping heat. The urgency of the climate crisis demands action. But what if, in addition to reducing emissions, we could find a way to directly counteract the warming itself? This is the ambitious and controversial proposition of solar geoengineering. Solar geoengineering encompasses a range of technologies designed to deliberately alter the Earth's climate system by reflecting a small fraction of sunlight back into space. Imagine a planetary sunshade, subtly dimming the sun's rays to cool our planet. The concept might sound like science fiction, but it is rapidly emerging as a potential tool in our fight against climate change. Proponents argue that solar geoengineering could provide a crucial stopgap measure, buying us precious time to transition to a clean energy future. Critics, however, warn of unintended consequences and ethical dilemmas. Could we be unleashing unforeseen risks by tinkering with the complex and interconnected systems that govern our planet's climate? The stakes are high. The decisions we make today about solar geoengineering could have profound implications for generations to come. We must proceed with caution, guided by the best available science and a deep understanding of the potential benefits and risks of this powerful technology. The promise of the solar geoengineering lies in its potential to rapidly cool the planet by reflecting sunlight away from the Earth. One proposed method involves injecting tiny reflective particles, such as sulfur dioxide aerosols, into the stratosphere. These particles would act like miniature mirrors, scattering sunlight back into space and reducing the amount of solar radiation that reaches the Earth's surface. This approach is inspired by natural phenomena such as volcanic eruptions. When Mount Pinatubo erupted in 1991, it ejected millions of tons of sulfur dioxide into the atmosphere. This massive injection of aerosols had a measurable cooling effect on the planet, temporarily lowering global temperatures by about 0.5 degrees Celsius. Solar geoengineering could offer a suite of potential benefits. It could help to mitigate the worst effects of climate change, such as rising sea levels, extreme heat waves, and changes in precipitation patterns. It could also potentially save lives by reducing the number of heat-related deaths, particularly in vulnerable populations in developing countries. It's important to note that solar geoengineering is not a silver bullet solution to climate change. It does not address the root cause of the problem, the accumulation of greenhouse gases in the atmosphere. Rather, it is best viewed as a potential supplementary measure, a tool to be used in conjunction with aggressive efforts to reduce emissions and transition to a sustainable future. The concept of solar geoengineering might seem like something out of a science fiction novel, but the technology required to implement it is surprisingly within reach. Scientists and engineers are actively exploring various methods for reflecting sunlight away from the Earth. One promising approach involves using specialized high-altitude aircraft to disperse reflective aerosols into the stratosphere. These aircraft would need to be capable of carrying large payloads of aerosols to altitudes of around 20 kilometers, well above commercial air traffic. While the basic technology for aerosol injection exists, significant advancements would be needed to develop aircraft with the necessary payload capacity, range, and altitude capabilities. Additionally, a global fleet of these aircraft would be required to maintain a continuous veil of aerosols in the stratosphere, ensuring consistent cooling effects. Other proposed methods include brightening marine clouds by spraying seawater into the air, which would increase their reflectivity, or even installing giant mirrors in space to deflect sunlight away from the Earth. These approaches, however, are currently less developed and face greater technological and logistical challenges. The feasibility of solar geoengineering hinges on our ability to develop and deploy these technologies on a global scale. While significant challenges remain, the rapid pace of technological innovation suggests that solar geoengineering could become a reality in the coming decades, if not sooner. Despite its potential benefits, solar geoengineering is not without risks. In fact, the potential unintended consequences of tampering with the Earth's climate system are a major cause for concern. Imagine for a moment a world where we have successfully deployed solar geoengineering and managed to temporarily cool the planet. What happens if we suddenly stop? This abrupt cessation of solar geoengineering, known as termination shock, could lead to a rapid and catastrophic rebound effect, with global temperatures spiking dramatically in a matter of years or even decades. This sudden shift in climate could have devastating consequences for ecosystems, agriculture, and human societies, far exceeding the impacts of gradual climate change. Moreover, solar geoengineering addresses the symptom of climate change, rising temperatures, but not the underlying cause, the accumulation of greenhouse gases in the atmosphere. While we might be able to mask the warming effects temporarily, carbon dioxide would continue to build up in the atmosphere, leading to ocean acidification and other potentially irreversible changes in the Earth's climate system. There's also the risk of unintended regional climate impacts. While solar geoengineering might cool the planet on average, it could also lead to shifts in precipitation patterns, potentially causing droughts in some regions and floods in others. The uneven distribution of these impacts could exacerbate existing inequalities and lead to political instability. Section 5. The ethical dilemma. Who controls the thermostat of the planet? The prospect of solar geoengineering raises profound ethical questions about our relationship with the planet and our responsibility to future generations. If we have the ability to engineer the Earth's climate, who gets to decide when and how to use this power? Who benefits and who bears the risks? The potential for unilateral action by a single nation or a small group of nations is a major concern. Imagine a scenario where one country, facing existential threats from climate change,